Hi everyone, this is a PCB that's part of another project. So this particular circuit that I've already made is part of my tube amplifier that's going to be battery operated. So I need to keep an eye on the lithium battery charge level. So I'm using a battery management system, but if you've got a defective battery, this will tell you if one of the batteries isn't quite charging to 100%. So here's the PCB. I've made it as compact as possible. A lot of the chips are actually close, so close that they're touching, which is the maximum or the minimum distance. They can be close to each other. So it's double-sided, so you have the LEDs on one side and the LM3914s on the other side. So I'll talk about the components later. The trace widths are the minimum or more, depending on amount of current. So this is obviously a very low current circuit. So the trace width is, in most cases, the minimum allowed. Some of it's higher. For example, the ground return paths are slightly thicker. I've used SMD resistors, normal electrolytic capacitors, and a couple of switches. The batteries are tested individually, and you have precision variable resistors or potentiometers for adjusting the lower level and upper level. So it's not just for measuring lithium batteries, you can use it for pretty much anything else. It doesn't need an outside power source. Each chip is powered from the battery itself, which is really convenient. So let's have a look at the actual PCB that's been probably made. So these I got from AliExpress, so 20p each, and I'll show you later when I turn them on. They're actually coloured and really high quality. The only thing I did find is this is pin 1 and this is pin 10, so they made this the wrong way around. I don't know what they were thinking. It did mean when I designed all this, it's the wrong way around, so I spotted it before I fabricated it and then flipped everything around. It actually worked well. It actually meant I could put it even closer together, so maybe it's a good thing. I've made some notes here on the voltage. This is obviously specific to me. I wanted it to measure the maximum voltage of 4.25 volts that I'm going to charge it to. I'm interested is when it reaches 3.35 volts and I'm ready to charge the batteries again. Then you have the JST PH connectors for the 4 batteries, all individual. The 4 LM3914s, these are fakes obviously. I have got some actual genuine ones on order. They're really expensive, £5 each. I've got 4 on the way. Some precision, what are they, 50k and 5k potentiometers for adjusting the lower and upper voltage detection or input. I can't remember. So it's a voltage divider circuit. I'll show the schematic. So let me connect up some batteries. Unfortunately I haven't had a chance to make the other 2 JST connectors, but it all works individually. I'm just going to connect them up to these batteries. Unfortunately I don't have any lithium batteries that are actually out of sync. All my batteries are in sync, so you're going to see the same. I do have this. I didn't make this. This is just a buck converter. I'm going to adjust the output voltage, then you can see the voltage go up and down. So let me connect all this up. Here we go, all connected up. So I've got one connected to a single battery here. This is halfway charged, so 3.7 volts, and I'm outputting 4.1 volts here. So the first button does the first 2 batteries. So you can see when it's 4.1 it's this this LED here, and when it's 3.7 volts it's this one here. So it's about half a volt per LED. So I'm just going to keep this button held down. If I just hold this, and then let's adjust, where is it, this one here. So 4.25 volts, it's a blue LED, 4 greens, 3 oranges and 2 reds. If I go down, 4 volts, 3.5, and then this is probably below 3.35, so let me just increase that. There you go, 3.35 volts. And then you can adjust the lower and upper LEDs using these ones. So this one I think adjusts, so they're in pairs. So this is for the first LED segment, second LED segment. So this is for the bottom end, top end. So you just need to make sure you input the right voltages when you make the adjustments. It's best to start with the potentiometers halfway, which I find is actually more or less close to the what you need in the end. You just have to make small adjustments. So let's have a look at the schematic and bill of materials. So here's the schematic for the LM3914 battery level meter. So you've got your LM3914 pins 1 and then 10 to 18 are the output pins. I've had to reverse it because of the output LED segment is reversed for some reason. Wrong way around, it doesn't matter. So according to the LM3914 and Texas Instruments PDF, it says the all the ground need to go to common ground and not kind of crisscross, so like a star ground. So that's how I designed the PCB. Then you have the two potentiometers, 50k, 5k. They have to be in precision, otherwise it's very difficult to set the LED levels. This capacitor here is recommended. Tantalum or electrolytic is fine, so I've used a 10 microfarad. It says one here is 10 microfarads. And then each circuit is then repeated 4 times because I want to monitor 4 batteries. There's the connectors there. So it's a really simple circuit. So if you were just after one lithium battery level meter, you just need this and a couple of JST connectors and you're done. So let's have a look at the PCB. So the minimum trace width is 0.35 mil, I think. Let me see if I can find a smaller one. 0.3 is the minimum. There's, I think, something like 30 vias on this because of the very small compact PCB and the components so close to each other, but as you saw, it works perfectly fine. If I have a look at the 3D model, 3D view, I haven't populated all the 3D models, but not necessary. Yeah, very close to each other. So the way you have to solder it is you have to have the chip on the little inline dip connectors. So you solder in the inline dip connectors, so you can't use the full IC sockets because it gets in the way, because you have the pins of the LED segments just underneath. So you solder in the dip connectors. You can get inline dip connectors, or you can get the chip, the main chip dip connectors and cut them or saw them. Quite easy to do because it's brittle plastic. So you solder that in first, which is on this side. Then you put the so you do all of them first on this side. Then you solder in the LED segments. Once you've done that, all good. The rest of it's easy. So let's have a look at the bill of materials. So not many components. Obviously quantities increased by 4 because I've got 4 circuits, but really you need 1 of each. Most expensive thing is the LM3914. If you buy a genuine one, obviously you can buy really cheap ones on eBay, so I've ordered some genuine ones. About £3.50 then. So I'll post all the information in the link below. Thanks for watching.